So today, our topic is Newton's method. Newton's method is a method for finding successively of the root better approximation to the roots of real valued function. So we have a formula to find it. So x sub n plus 1 is equals to x sub n minus f of x sub n over f prime of x sub n. So this f prime of x sub n is the derivative of the function. So let's have an example. So our example here is x sub 3 x cubed minus 4x squared plus 1. So before finding the interval, we should have a changing sign. So if when we substitute the value, we have an initial guess. So if we substitute the value of our initial guess to this equation or to the function, if we have a result of changing sign like this one, we can say that the roots lies between this interval. So I have an initial guess of 0 and 1. So when I substitute the value of 0 cubed minus 4x squared plus 1, so it just equals to 1. Then when I substitute the value of 1 here is 1 cubed minus 4 times 1 squared plus 1 is equals to negative 2. So since we have a changing sign here, the roots lies between 0 and 1. So let's compute for the at least 4 iteration. Before that, we will need to find the derivative of the function. So the derivative, so f prime of x sub n is equals to 3x squared minus 8x. So let's solve it. So since we have these two interval, we will get its half, or we'll divide it by 2. So we will say that is our initial value for x sub 1. So 0.5 is our initial value for the x sub n. So when we go now find for the x sub 2. So x sub 2 is equals to, it is our formula so that you guys can see, over f prime of x sub n. So well, now that, so we have the value here, so we have 1 plus 1 plus 2, so we need to find the x sub 2. Oh, so now 0.5 minus so again x sub 2 is equal to 0.5 minus the f of x sub n. So when we substitute the value of 0.5, 3 times 0.5 squared minus, I know, here, we will substitute first here. So 0.5 raised to 3 minus 4 times 0.5 raised to 2 plus 1 is equals to, okay, let's just put it down there. 0.5 raised to 3 minus 4 times 0.5 raised to 3 plus 1 over 3 times 0.5 raised to 2 minus 8 times 0.5. So we have a value equals to 0.5385. So when we find the last third iteration, since our problem is we just need to find the third iteration, so we will substitute this value of x sub 2 to our x sub 3, so we can find the value of x sub 3. So x sub 3 is equals to 0.5835 minus 0.5835 cube minus 4 times 0.5835 squared plus 1 over 3 times 0.5835 squared minus 8 times 0.5835 is equals to our third iteration, or for our value of x sub g, is equals to 5.4136 times 10 raised to negative 6. So, if you guys know if you're the better approximation, when you can find it by have a formula of the new iteration minus old iteration over new. When the approximation or the value or the percent error is low, that means that you have a better approximation or where the roots lies between. So that's all. Thank you.